So now that we've looked at using Microk8s for local development around containers and Kubernetes, I'm now going to show you how to utilize Kubernetes as part of a CI/CD pipeline for Kubernetes integration testing without the need for a full-scale Kubernetes cluster. Now, in order to run GitLab, which is the main tool I'm using to provide a private registry and also source control solution, and also the pipelines itself without Jenkins, I've deployed all of that stuff on top of Charmed Kubernetes. Now, Charmed Kubernetes is Canonical's supported distribution of Kubernetes for large-scale deployments. It's fully supported by Canonical on a variety of platforms, including most of the major public clouds, AWS, Azure, and GCP. It's also supportable on VMware, OpenStack, and bare metal. In this case, I've deployed it using AWS, and I've also set up GitLab already. I'm not really going to be covering the deployment steps. However, the steps for doing so will be provided at the end of the session later on in the week. But as part of this this demo, I'm not going to be covering or showing the end-to-end deployment of everything. I will be covering GitLab and some of the stuff around that in more detail. But just to get started, I'm going to show you some more tools that we have in our toolbox. So the first of which is called Juju. So on, again, my Ubuntu workstation, I've done a sudo snap install Juju. Now, I already have it installed, so I'm not going to run it again, but once you've run this command, you'll have the Juju client installed. But it won't have any credentials set up. Now, Juju is Canonical's tool for application modeling. We use this to deploy OpenStack. We use this to deploy things like Kubeflow, Kubernetes, and a variety of other tools. You can also use this tool to deploy containers on top of Kubernetes as well. And Juju uses something called Charms. Now, Charms can be thought of like Puppet modules or Ansible roles, or essentially modules of code. And for configuring, installing, upgrading, reconfiguring, scaling particular services. Now, I already have this set up, but essentially when you've installed this, there's a couple of things that you'll need to do. So one of them is add credential. And if I just put in AWS, credential, you'll be prompted to put in a name. And on Amazon, this is essentially your IAM credential, which is your API key. So if you have one of these generated and that account that you've used has the specific permissions to provision machines and also set up security policy rules as well, for the firewalling, it will suffice. But there are some quite detailed steps in the documentation. So this is on the Juju discourse. This explains the IAM credential permissions you need and how to do this in detail. So there's an example here given in the documentation which explains how to add credentials, how to set that up, but I've already done all that. So the next step for me to do would be then to run the Juju bootstrap command, and the bootstrap command will create what we call the controller node. Now, the controller node is essentially it's a bit like a puppet master, because Juju is an active solution. It doesn't just do a one-off deployment of a solution. It will actively monitor it over time in case anything breaks or becomes unresponsive, and you have a way to check it, and then obviously apply any reconfiguration changes, etc. over time. Now, I've already done this as well, so I don't need to do this again, but once I've done that, I can then check that I have some running. So you can see here that I have one called EU West 2, even though it's running in the US East because I accidentally gave it the wrong name. But you can list here that the controllers that you have available. Now, the next command that I'm going to do is list models. Now, as I said, it's a modeling solution, and the same set of controllers. So these are essentially the machines which keep the persistence in the state. They're actually capable of modeling multiple different models and maintaining those. So what do I mean by model? Well, in this case, it's a deployment of Kubernetes, which is modeled as part of this default model. But I can easily add another model. So let's just add Juju, and I'll call it Charmed Kubernetes. So add model. So In the default model there, you see it has 5 machines and 12 units. So this is where I've already got Kubernetes running, and I've added a bunch of extra machines to do extra things outside of the scope of the cluster. Now I've added in another model, so if I run Juju list models, you'll see here that there's a new model created, and there's no machines, and there's never been connected to. So, and it's automatically put me into that model. Now I'm going to deploy, so if I wanted to deploy Charmed Kubernetes, the full scale thing, I would run this command, and this will deploy the full scale Charmed Kubernetes. However, as this is a demo, and I want to save on cost and that kind of thing, I'm going to deploy something called Kubernetes core. Now I've already done this and I've already set it up, and as part of the materials and the tutorial that will come out, like the step-by-step guide, you'll see there's already what we call a bundle file. Now a bundle file is like an Ansible playbook, or essentially like a collection of Puppet modules together, along with their configuration and the relationships between those modules, all put into a file together, which is nice and neat in YAML, that explains how the deployment works. And all of that's included, and there'll be some steps in the guide on how to set that up. But I've already done it, but I'm just going to show you how to deploy this if you wanted to, just understand at a high level how this is working. So all I need to do is just run Juju deploy Kubernetes core, and this will actually deploy a slim, trimmed down version of the Charmed Kubernetes distribution for me. So I'm not going to sit around and wait for this to deploy, because this will take a good half an hour or so. Well, it's usually about 15 minutes. But then the rest of the steps, like deploying GitLab and all that stuff, will take a good while. So I'm going to switch back to my other deployment in a minute. But just to monitor it, and just to explain in a bit more detail what's going on here. So if I run the Juju status command, you'll see here that it's provisioned, and I can watch this while it's deploying. If I was to jump onto Amazon right now, you'd see that Juju is essentially provisioning all the machines that it needs. And then once it's provisioned the machines, it will then provision all of the services on top as well. You can monitor this. Essentially, it will all turn green once it's ready, ready to be used. And yeah, I mean, that's quite straightforward. It's deploying the machines, and if I jumped onto Amazon, you'd see them all being spun up. And then it will deploy all of the services afterwards. And you can see in here that each of the different charms has an application name, and it has a different revision of the charm, because each one of these is independently revisioned and then released as part of a release every so often as well. Now, Juju itself is a command line tool, but it does have an optional GUI as well. So if I jump onto the GUI here, yep. You can obviously restrict all this stuff with back as well if you wish. You'll see here, this is the simple Charmed Kubernetes model. You'll see here that so each one of these circles represents one of the charms, as I was discussing. These are essentially modules of code, which they're responsible for the operational task behind a certain service. So in this case, there's one for EasyRSA, which is used to generate the certificates, the SSL certificates for everything. There's one for etcd, the Kubernetes worker, the Kubernetes master service, and there's also one here for containerd, which is a subordinate charm, and there's also one for Flannel, which is the CNI plugin. So in Kubernetes land, you have what are called CNI plugins, which are container network interface plugins, and because Kubernetes itself has a swappable SDN interface essentially. So if you wanted to swap this out for something else like Calico, or it could be a Cisco ACI plugin, Juniper Contrail plugin, you can do that quite easily. You can also swap out the runtime, the container runtime as well. So right in our default distribution, we're using containerd, but you can swap this out for Docker, or if you're using NVIDIA GPUs, for example, they have their own runtime. But there's a couple others out there as well, like Kata from Intel, which is used to provide a bit more security around your container runtimes by utilizing the virtualization instructions of the CPU, i.e. VTX and VTXD, those kind of things. And you can see here that you have etcd, for example, and so these are all charms, and these are all essentially modules of code that handle the operational tasks, and it's all pre-written, typically in Python. These handle the installation, configuration, reconfiguration, upgrades, scaling, everything. And the lines you see here, these are all the different relationships between the services. And this is one of the ways in which I think Juju differentiates itself from a lot of the other solutions out there, because they don't model these relationships. So if I wanted to scale etcd, Juju understands that that has an impact on Flannel, or it has an impact on the Kubernetes master or worker services, either directly or indirectly. And therefore, if I do scale, I need to then go and update my configs for, say, the master service to understand that some additional units of etcd have been created. So the GUI is totally optional. You don't have to use it, but it's just there really for a high-level overview. You can do everything I'm doing on the command line through the GUI as well, but generally we stick to the command line interface. So I've already deployed this cluster. The one I've just deployed will be up in a while, but I don't plan to really utilize that. So in order to deploy GitLab, and again, all of the instructions are included as part of the README that will be sent out after this webinar. I'm going to use something called Helm. Now, I've already, as part of the previous instructions, set up Helm, or at least installed the client. So that's the command. I already have it set up, but that's the command to install it. And once Helm is installed, then you do a Helm repo update. And you can see here I've already added a couple of charts repositories. So Helm is, if you've never used it before, Helm is essentially like a package manager for K8s. So there's a bunch of pre-built charts out there which come from different vendors like GitLab, for example. And what I'm going to do is just list models again. So I'm going to switch over to my default model. This is the cluster I've already built, but once the Kubernetes cluster is built, I'm ready, so I can just show you what that would look like. It would look a bit like this. So you can see here there's a couple extra nodes in this cluster, but that's basically what it looks like. But once it's all green like that, you can then interact with the cluster by using the kubectl config command line tool, which interacts with the Kubernetes IO, just like I was doing with Microk8s. If you remember from the previous example, I was using Microk8s.kubectl. Well, to interact with the, an existing Kubernetes cluster, I can use the same thing, but I need a config file, right? Now, in order for me to make use of this, I need to do one thing. So the first thing for me to do would be to, in my home directory, create the kube folder. So once I've created that, inside this folder I need to create a config file. And that config file is called, it's actually just called config, and this is what stores the Kubernetes CLI tool config. So it just makes my life a little bit easier, rather than every time I want to specify a command, I don't need to specify the config and the credentials I want to use. And Juju has some quick automation for me to just copy that config file over. So if I run this command, Juju SCP, this will copy the kubectl config file from the master server over to my local machine so I can interact with the cluster. Now, I already have one running, and I've already done a Helm repo update. But the next thing that I would have to do is deploy GitLab. And the way that I've deployed GitLab is using Helm, so it's based on the upstream Helm chart, and you can see this is the example I've used, and this will be again made public after this webinar, but you can see here that I'm deploying the CE version, which is the community edition. So this is free to use. I've disabled the ingress controllers because as part of Charmed Kubernetes we are shipping our own ingress controllers which are already enabled, so I don't need to redeploy any. I've also set the domain to cavernh.com. Now I've already set up my DNS servers to point to my worker nodes. I've already done that. But if you're planning to use this in production, you might want to do the same thing. I've also disabled Cert Manager because I've already actually deployed Cert Manager and configured that to use Let's Encrypt. And this is quite important because I want to use SSL certificates everywhere in production, right? So, and I also want to make sure that the SSL certificates I'm using are trusted by all the clients that I use. And when I deploy GitLab, there's multiple different services, and each one of those expects to be able to interact with an SSL endpoint, HTTPS. And those endpoints need to be trusted by the other services. So, for example, there's something called the runner. The GitLab runner is the component which will do the continuous building whenever I check in some code. And that's quite important because it interacts with other services in the cluster, and if it doesn't trust something, it will give me a warning and an error, and it won't work. So I've deployed something called Cert Manager. I've done that through Helm. I've deployed and configured it to use Let's Encrypt, which is a free CA, public CA certificate authority, which you can use to automatically sign certificates. This is trusted by most major browsers like Chrome or Firefox, which is really useful. And I've already used built-in ingress controllers. Now, if you run this command, this helm install, this will actually deploy GitLab for you. I've already done this on my cluster. But basically, once you've got everything set up properly, you should be able to then access your GitLab installation. So I've already set it up on this cluster. But if you go into here and but for the first time, you'd have to register and create an account. Now I'm just going to jump in with my existing account. So it's Calvin H, and then a password. So once you come in here, and as part of the documentation that's going to be made available after this webinar, there's a full series of screenshots of what to do in here, what to configure, what to set up in a step-by-step manner. But basically you'd go in and you create a new project. Now I've already created one called Webinar, Microk8s Webinar, and I'm set to the maintainer. And by default, GitLab does also deploy a registry as well, which is quite useful. And that's what I pushed. If you remember earlier, I created a container and pushed that container to a registry. That's the registry that's built into this GitLab that I've used. So within the enterprise, if you're looking for a single solution, not just to manage your source code, but also to manage your container images that you're building, and also to do your CI/CD, GitLab is a single solution which can do all of that out of the box. And it's really quite impressive the amount of functionality that you get from this product for free. So I've created this project. I have checked in my code. So if you remember earlier, I had there's a test script which I mentioned, which I didn't run earlier, but that's in here. This will be used quite heavily in a minute. I've got a Docker file, which is the same one I used earlier. So if I just click into this, you'll remember that this is just my Ubuntu container, which is running a static web page with the simple picture of the cat, as we saw earlier. And then finally, there's the manifest file. Now, I use the same manifest file to deploy on my Microk8s cluster that I'm also going to use to deploy into my production cluster as well. And so that's really cool because it means there's no difference. Whatever's running on my Microk8s cluster will also run on my production cluster. And I can almost guarantee that they're the same thing. So yeah, that's the repo. When it comes to CI/CD and GitLab, the main thing to look for is this gitlab-ci.yaml file. Now, this is a special reserved file which is used by GitLab for essentially a pipeline. Now, I'm just going to click into this. And what you see in here is some simple syntax and there's several stages to this pipeline. So I'm just going to talk you through this. So, obviously, a CI/CD pipeline is different to all businesses. The amount of testing that they do will definitely vary depending on the application and how critical it is to the business. Obviously, this is a very simple example of a single static web page served in a static web server. There's not like a 3-tier web application going on here with multiple microservices and lots of complexity. So the amount of testing I can do really is very limited. I could, of course, write some extreme integration tests and some unit tests and several other test suites around this, but it's just for this example, it's not really very necessary. However, for your applications, you will most likely want to do that. Now, I've defined 4 stages here. So I've put in test, build, Kubernetes test, and deploy. Now, Kubernetes test is more like integration tests. And this is the section which actually utilizes Microk8s. The test stage I would reserve for running, and I've put there pre-build tests like functional tests and unit tests. This is where you would actually be running your test suites for your code So for example, if you're running or building microservices, you'd most likely have a series of tests which would go with those. The build section is where I actually automatically build and push the container to the registry that's made available as part of Microk8s. Now, there's some special variables that are made available to this script through GitLab, which define the registry user, the registry address, and the registry password. And these can be used by the Docker client to automatically log in. Another thing I had to do here is because this is using something called D&D, and this means Docker inside of Docker. Because when you're running GitLab as containers, it actually creates these runners, and the runners are used to rebuild images dynamically and then push them to a registry, or just to perform a series of tests, etc. And this requires, it's already running a Docker image, so it's going to run Docker within Docker, and this requires a special piece of syntax here to enable that. So the steps here are pretty straightforward. This is actually what I did on the command line earlier with Microk8s. I'm just building the container and tagging it, and then logging into the registry, and then I'm pushing the container. And then after I've done all that, it's just echoing out to the prompt that it's built at. The real interesting part is here, where I'm actually making use of Microk8s as essentially as a solution for doing some integration testing. The really great thing about this is that you don't need a full Kubernetes cluster in order to do this testing. So you can dynamically deploy, provision, spin this up, install Microk8s, run your tests, then destroy the whole thing. It doesn't require a whole load of machines, like 12, 16 machines or whatever. Just a single machine can be very limited in its capabilities, i.e. it could have a small amount of RAM, a small amount of cores, and it's still able to do the job here. So in this section of the automation, all I'm doing here is, I'm essentially setting up SSH, and I have a separate machine set up to run Microk8s outside of the GitLab install. Now, bear in mind some of the stuff I mentioned earlier around like Microk8s clustering. It is definitely possible to set this up on a small Microk8s cluster running on, say, Raspberry Pis, where you have GitLab set up on a couple of the machines, and then one of the machines is running Microk8s, or the whole thing can be running Microk8s, and then one of the nodes could be dedicated for this part of the portion of the testing. And all this is doing is SSHing into that particular machine I've used just for Microk8s, and then it's running a series of commands, not to first remove Microk8s, basically to clear anything up that was already there. Then I'm installing it. Then I'm basically placing my my config file, which is the kubectl config file. And then I'm interacting with the Microk8s cluster using kubectl. And then I'm applying the manifest. If you remember, the manifest I just showed you, it's the same one I was using earlier. It's basically, describing the stuff I'm deploying on top of K8s. Then I'm running the CDK-cats test script. Now this script, and I'll show you this in detail in a minute, runs a series of it's almost like a simple assertions to say, have the pods been deployed, are the pods ready, have the ingress rules been created, are they ready, is the node port ready and available, can I get to the website on this port. So it's very simple. Obviously if you're doing this in production for a much more complex scenario, I would have some much more detailed tests running. And then finally, once all three of these sections have completed, so this is essentially your tests, your build, your integration tests, then I actually deploy the same workload onto my production cluster. And then I can actually check that, because if you remember, I'm using this calvin h.com endpoint, which is publicly available. I can then check that afterwards. Now, let me just dive back into the repo and I'll explain the tests again. So what's going to happen is when I run the pipeline, so if I go down to pipeline, the cool thing is you can monitor this whole thing through GitLab. That's really quite impressive. You can see how all the times I've been testing it, etc. So let me just hit run pipeline. And this will then kick off an end-to-end test, deploy and build. While that's running, what I'm going to do Let's go back into here. So on the machine running Microk8s, I've actually got some stuff already set up on there. For example, I've already pulled the repo, so as part of the pipeline, it will just do a git pull and it will get all of the latest stuff to deploy and test every time it runs. And inside of here, you can just see a very simple script. So it's just, this is what's pushed to the Microk8s node after it's deployed its containers. It's just saying, you know, can I access the Microk8s command line? Basically, if the Microk8s binaries are not available, then it's going to error out straight away. So usually this would show that the Microk8s snap has failed to install for some reason. Once it is installed and accessible, it will then use kubectl to just check that the ingress rules have been created. If they're not, then it will error out. The next thing it will do is check if the node port has been created. If not, it will error out. I've just noticed here there's a typo, so I'll fix that in a second. And then finally at the bottom here, it will basically check to see if the container pods have been created and if they're ready. Now this is important because you can create container pods, but they might not be in a ready state. If they're not in a ready state, most likely the container hasn't actually been run yet and executed yet, so there's something that has desperately gone wrong. And then eventually right at the bottom, it combines everything together, and then we'll check, you know, it will get the service, it will get the IP of the service, and then it will actually try and hit that endpoint with a curl to see what the response is. If it's a 200 response, then we know that the website's available. Now, this is a very simple example, right? But if you're running a microservice, you'll probably want to do a lot more tests than this. This is just a very, very simple example of how you can do some simple integration tests with K8s and Microk8s together using something like GitLab. So I just kicked off a pipeline build, and if I go back to the pipelines, what you'll see in here is you'll see it's running, and I can go into each of the different sections. So you can see here it's running the tests. So you can see there that it's deleted Microk8s from the existing machine. And then it's going to, it's reinstalled Microk8s as expected. And now it's going to run the test script, and we should see the output from that in a second. Now, just going back to Charmed Kubernetes again, so Canonical provides not just breakfix support for Ubuntu and Kubernetes, Charmed Kubernetes and Microk8s, but we also provide a managed service as well. And this is, we have customers all over the world using this in different lines of business, telcos, banking, all lines of business use this service from us. So you can also see here, so it's redeployed everything, it's found that the ingress rule and the node port rule has been created, and the script has been written so it will actually retry each of the steps. If it doesn't work the first time, it will retry the steps up to I think a total of 6 minutes, or 5 or 6 minutes, and until it's ready. And because it's a very simple workload, it doesn't take long at all. And then we can see here that the job has been completed successfully. And then eventually what we'll see is the next step, which is the actual deployment of the workload to production. So this is going to interact with a different Kubernetes cluster I have running. And the way that it's going to do this is using something called variables within GitLab. If I just expand on this, you'll see here I've defined a series of variables. Again, these will all be defined and described in the documentation that will come out with this webinar as to how to set all this up. But you can see here that I've defined kubeconfs. So within these variables here, I actually have the whole kubectl config files that I require to interact with those clusters to deploy workloads on top of them. And then right at the bottom, we can see here that it's succeeded, it's created everything, and then if I go to the browser, I can hit this now on the public endpoint. So what I'm going to go ahead and do is actually modify this and then show you end to end that it's being rebuilt and published. So container. So let's make it do something else. So let's make it, for example, wrong file. Let's go to HTML. Let's make it say something else. I've just modified the HTML, so basically the message on there will be different. Oh, my bad. So it's just saying there that basically my repo, the version that I have checked out at the moment, is older than what's in the repo. That's because I've been modifying the files directly. So I've just pulled in the latest changes, and then I'm just going to commit again. Yeah. There we go. And then what we should see is, after I've done that, if I go back to pipelines, you see it's now got pending. So you can see here that I've just pushed code basically, and you can go in, you can see what I've changed. So you see there that some slight changes. Again, we can see it's getting through the stages again. Eventually, it will run through all of the workload, and the new container will be pushed to the production cluster, and then we should see our change come up automatically for us. Still running the test on top of Microk8s. Because I've changed the container, this most likely will take a little bit longer because it's pulling in the new version and getting ready to roll it out. I can see there that it's succeeded. And finally, the deployment is pending. We see the container has been deployed, so if we hit F5 we should see a new, there we go. The new container has been deployed and everything's working. Now, I can also break this, so for example I could go in and it's quite easy to break this workflow right now. For example, if I went in and I edited the manifest, so if I went in and for example if I change this to say 1 for example or something else, this would actually, and then checked it in, it would rerun the pipeline, and then the pipeline based on the simple test I've written will actually figure out that it doesn't have enough replicas and it will break. So that's something else we could test out and we could show that running as well. But yeah, this is just a very simple example of how you can use CI/CD together and how you could use Microk8s as part of that pipeline essentially to do that testing. It's a very simple example, but the techniques and the tools apply to much larger applications and much larger projects. So hopefully this has been of interest. I feel free to answer any questions you might have. Thank you very much for watching.